Okay. If you have not completed this question, you should listen. If you have done it, move to the next one. So show that this is equal to this. This is easy, right? So we don't need to worry about the A part. The B part. Hence or otherwise, prove that the sum of cubes means something cubed plus something cubes. Okay? Sum of cubes of any two consecutive integers. Odd integers actually, right? Any two consecutive odd integers. So the first one must be odd, and this must be this odd plus 2, because two consecutive odd numbers differ by 2, right? So an odd number is 2n plus 1, right? So the next one could have been 2n plus 3. But you won't really achieve your aim here, because it means you are trying to prove this, right? But there's no need for that, because the odd number before 2n plus 1 is just when you minus 2, and that is 2n minus 1. So this could also be the consecutive odd numbers. This could be the consecutive odd numbers. This could be 2n plus 5, and this also. They are also consecutive odd numbers. So you don't need to worry, because you have done A part. So in order to link it with B, you just take this and this as the odd number. So the first thing you say would be, let 2n minus 1 and 2n plus 1 be the consecutive odd numbers or odd integers. Okay, odd integers. So you want to prove that the sum of their cube is divisible by 4. So now you want to prove that 2n minus 1 cube plus 2n plus 1 cube is divisible by 4. So rather than expanding this again, you don't have to, because you already got something about it, which is what? 16n cubed plus 12n squared, right?
No, only 12n.
Just n. So what you put in brackets? From A. Okay? To prove that something is divisible by 4, what does it mean?
No remainder.
Say that again?
There's no remainder.
When what happens? Don't just say no remainder. That's an incomplete statement.
16n cubed plus 12n divided by 4.
And there's no remainder when divided by 4. But we don't want to divide. So how can you show it if you don't want to divide? You factorize the 4 out. So 4n cubed plus 3. That is all. That's it. So if you are able to factorize 4 out, it means yes, you can divide by 4.
This is 3n.
Well, that is something wrong? 3n. Okay? So with this, then I can conclude by writing. So I can conclude by writing, so since this is equal to this, then it implies that this is how you write something divide. A divides B, just like 2 divides 8. 2 can divide 8. Okay? So it means 4 indeed divide 2n minus 1 cubed plus 2n plus 1 cubed. 4 divides this. It means this is divisible by 4. Okay? So the second question I posted on WeChat is induction. Just a minute. Is it? Yeah. So this is the second question on WeChat. You make this one?
Yeah.
6C. Okay, so prove PK first. So we want to prove that this is also true. Okay. So we start with PK plus 1. What would keep it pk plus 1? Since we want to prove that this will be by 6. Okay. But we already have something for pk. You have to be able to get something here that can substitute here. You have to be able to use the inductive hypothesis here. Has anyone completed this problem? You see, you have to be able to use the inductive hypothesis when showing pk plus 1. But you didn't use the inductive hypothesis at all? What? You didn't use it? You should be able to use it somewhere. Okay, very good. That's what we want to do next. I think the problem with most of you will be, Brandy, that is not how to do induction. P1 is equal to that, P2 is equal to that, Pk is equal to that, Pk plus 1, what is that? That's not the inductive process. You have to follow the inductive process. Where is it called? They just say he's very tired. At what time? Lazy boy. Ask you by the way.
How did you get this earlier? Like you combine the two.
Wait, why do we have the two crystals sitting together? Is it to create confusion? No. Because you're what? Oh my god. Now I need my best friend also. Oh. Okay. Shall we look at it together? Brandy, I've said it before, so please pay attention. To prove by induction, you check for maybe P2, for example. Then you assume PK. You have to be able to write those keywords. Your communication is a key in IB criteria. It's not just writing. How you communicate is very important. You check for P2 or P1, or maybe P1 and P2. Then you say, assume PK is true. You don't write PK is equal to. No. You have to be careful. So let's check for P1. So the first thing, what is P something? Do you mind? So you check, you call it PN. You're being noisy, that's my point. Don't pretend you don't know what I'm talking about. PN is a problem. So because nobody said anything about PN. You introduce PK. So what does that mean? You need to define what that means. Let PN be the statement. What statement? This statement. The statement that this is divisible by 6 for all n. Okay? Let Pn be the statement n plus that. Instead of writing all this, you can write this. Let Pn be the statement 6 divides for all positive integers n. That's Pn. Again, this means divides. 2 divides 8 means 8 is divisible by 2. Okay? 3 divides 15. Do you agree that 3 divides 15? Okay? 3 divides 15 means when you divide 15 by 3, there's no remainder. 3 goes straight into 15 without any. 3 can be factorized out of 15, basically. So this is a symbol for divides. So usually when you write this way, you write the divisor first. But here the divisor comes last. Am I making sense? So these two statements are the same, but this is a short form. Okay? Alright, so you can write the long one here, or you can write the short one. So let Pn be the statement that 6 divides that. I have introduced Pn, then I'm going to check for P2. So for P2, when n is equal to 2, for n is equal to 2, let's check. 2 squared, 2 bracket, 2 squared plus 5 is 2 bracket 9, right? Which is what? 18. Which is 6 bracket what? 3. So what does that mean? P2 is true. Now that we know that P2 is true, then you say assume that PK is true. It's an assumption. We need to see this keyword. Assume that PK is true. Now explain what you mean by that. Okay? It means for certain K, 6 can divide it. It means 6 divides K squared, n squared. Okay? Now what does this mean? It means that when you have K squared plus 5, it can be written as 6, maybe M. Just like this is written as 6 times 3. This will be 6M, okay? Where M is some integer, positive or negative, we don't care. Wait. What is it? Oh, and yeah, that is K. K must be greater. We're not talking about. Okay. But definitely it will be positive because it is square, right? So I'll just say that. Okay, this is for n. N is what you're iterating, the numbers you're substituting. Just like K. K cannot be negative. So this is the inductive hypothesis. Now, from here, I always leave some space. Because I know that I need to manipulate this to be able to substitute back later. So I'm going to leave maybe about 2-3 lines here. So now, to prove, can you see I'm explaining? To prove for these, I'm not just writing P1, P2, PK plus 1, no. Okay, you are teaching somebody on your paper, even though the person cannot see you, right? To prove this, that is, I want to prove when K is equal to, or you can, even if you don't want to write to prove this, you can say when n is equal to K plus 1, alright? When n is equal to K plus 1, that might be a better way to put it. Of course, that's what we want to prove. So when n equals K plus 1, okay, we have K plus 1 squared plus 5. This is what you want to simplify until you can factorize 6 out, right? So you have K plus 1, this is K squared plus 2K plus 6, correct? Okay? Now we need 6. Clearly we need to expand, because unless 6 can come out from here. So let's expand. If you expand, make sure you don't have more than one equality on the line. Mr. Long specifically told me that someday. So I was like, oh my God, I thought I was the only one checking this. Because I was talking about IB presentation and communication. So we was talking about some of the things that students take for granted. Writing equals to all the time. Like this, for example.
So is that okay?
It's not okay, that's what I'm trying to say.
Oh.
Unless I could use implies or implication. Yeah. I could
implies
use implies this.
is not.
Not just too many equality sign on a single line. Alright, anyways, especially when you have long expressions. You want to take it to the next stage. Okay, let's expand quickly. You have k cubed, 2k squared, right? Plus 6, then k squared, 2k plus 6, am I right? 6k. That's 6,000. That's a lot of money. Am I right? Okay. So simplifying this, you get k cubed, 3k squared, yes? Followed by what? 8k plus 6. So, you can see I have cube, right? So I come back to my inductive hypothesis. K squared, k into bracket, k squared plus 5 equals 6m, right? This implies that, if you open the bracket, k cubed plus 5k equals 6m. So you can make this a subject and put it here. Okay? So if you make that the subject, k cubed will be equal to 6m minus 5k. So that's why I left the 2 lines, because I don't know what this will look like, so I know what to take from here. Okay? So, if you put this, then you say 6m minus 5k, hopefully it works, right? What else? No, there's not. This is redundant. 6m minus 5k, then plus what? 3k squared plus 8k plus 6. I can't see my 6 yet.
I think you can just like make K the subject.
Make it the subject?
Pull the 6 out.
If you make k the subject, or the 6 comes out?
Yeah.
Okay, let's see. If we make k the subject, or make 5k the subject, but we don't have 5k all through. Okay, if we make k the subject like you said, but does it cancel out our q from here?
You can cube it, but you still pull the 6 out because it's 6m on the numerator.
Oh, you sure?
Because
Let's try that. So, from here, if you make k the subject, you get,
I mean, like, just make K equals to 6m over K squared.
like this one, but this one?
Yeah, we just.
Okay, k equals 6m divided by k squared plus 5.
We just substitute that.
But when you factorize out, what is left must be an integer. Are you sure what we have left in that bracket is an integer? You have to think about that. So let's see if there's another way to use the inductive hypothesis, because I don't think that will work. Okay, wait a minute.
Mr. Daniel,
Yes.
can we just use different forms of that first equation for different k's?
What do you
so
mean?
Like, for the first, no, so down there, you see k cubed. No, even lower. That's fine. Yeah. So in k cubed, we could use, we could do this equals 6m minus 5k, and for this one, we could use, we could like use this one, and then 6m minus k minus 5, or 6m divided by k. Wait, yeah.
If you divide by k and the 6 comes out, you have something like m over k. We are not sure if m over k is an integer. And you have to be able to get an integer. What am I missing? Usually, you just substitute one of them.
It's only 6 points. What is this?
You just substitute one of them. Usually, it's the k cube, like the power, the one with the highest power. But then, what is k squared? K squared also should be substituted. Does anybody have an expression for k squared?
K squared? What do you mean?
Because if you can substitute k cubed and substitute k squared, then I think things will be easier.
There is one, but we just said it didn't work.
6m divided by.
Just divided by k?
Divided by k minus 5.
Yeah. 6m divided by k minus 5.
No.
K minus 5.
Or multiply the
K minus
entire-
5 may not be 6m.
This is diagonal.
Yes.
Maybe you can multiply the entire equation by k.
From
And
which
that-
one? This one?
No, up there, up there, up there. Yeah, yeah. What if you multiply both sides by k, and then you'll be able to do.
You mean this one?
Yeah, yeah.
That's k to the power 4.
And then it'll be k, 5k squared, and then 6mk, and then you would be able to. If I go up marker,
Yeah, yeah.
because then you can do this. You can do.
Squared.
So
You're complicating the problem, I think. Because you have a k to the power 4. The idea is you want to reduce as much powers as possible so that the rest of them will be just factorization. That's the idea.
No, then you have a fraction sign.
Okay, let's see. Go back to this. So 3k squared and this is what? Wait, this is what? 3k, right?
Wait, that would be an integer, right?
Which one? This one? This one?
Because k has to be an integer.
Yes.
So if like k is an integer and two integers multiply together,
Oh, because k is an integer, then this has to be an integer? Is that your point? Okay, so what do you think we can do with that?
just substitute everything in.
No. If this is an integer, if it is an integer, what it only shows is that this divides this. It means anywhere you see k squared plus 5, it can be written as 6 times. No, anywhere you have 6m, it can be written as a multiple of this one. That's what it means. For this to be an integer, this actually divides this.
Yeah.
That's what that means. So are you saying if we substitute it, we should be able to write that way?
Then if we pull it out, it'll still be an integer.
So it will be a multiple of m, or multiple of 6. Is that what you're proposing? But if we pull it out, you're not sure if the divisor is here, which is 2 or 3, or if the what if this is 7, for example? If this is 7, for example, this is like 2, 6 is what is divided. So if you factorize 6 out, you're not sure if 7 all over that is an integer. You can only treat it as a whole. I don't know if you're getting my point.
So it's not
But-
going to be able to divide by 6.
See, these and these are okay. This is the problem. 3k squared plus 3k gives 3 brackets k squared plus k, right? Let's see. 6m plus 6, 3k squared plus 3k. So this gives actually 3k bracket k plus 1. And that doesn't do us any good. Okay, wait. If we make k squared the subject from here, like somebody said, so that would be 6 divided by something. 6 divided by, let's see what we're trying to see here. K squared plus 5 is 6m over k. So k squared is going to be 6m over k minus 5. Right? Is it? No. Then you have 6m minus 5k. Do we have 6m minus 5k? Yes. So 6m minus 5k divided by k. So, put this here. No, it still doesn't make sense much to me. But my concern is this 5 that is left as the denominator. Do you guys understand? That's my concern. If we put it this here, this is 3, not even 5 for them to like cancel out. So if I multiply this by 3, this is 3 divided by something of 5, and I don't want 5 at the denominator because the bracket will not be an integer anymore. What could be the problem? For all integers, I'm missing something here. I'm not using a particular clue. Or let's look at from this factorization. If we only focus on the bracket, I want us to just brainstorm and not just look at the solution, all right? So that's the reason I'm not showing you the answer. Let's brainstorm and see how to manipulate this. If we only focus on the bracket, which has k squared, let's see. This is simply k squared plus 5, okay? So, okay. Can we get this from here? This is k plus 1, k squared plus 5, then 2k plus 1. Something like that. Such that when this multiplies this, you get your 6m. K, I don't know if this makes sense, I'm just writing first. And k into bracket 2k plus 1. So this is your 6m automatically. But what becomes of the rest? You have another k squared plus 5, another 2k plus 1, another k squared plus 5, there's a division of, no, it doesn't make sense. Any other clue? I'm not thinking straight. What's going on? Any other clue? Billion, what did you get? Stock? This is strange. Yeah.
We tried not expanding the k plus 1, right? We already tried that.
What do you mean?
Like, we just look at k plus 1 squared plus 5. We already did that, right?
K squared, k plus 1 squared plus 5.
We looked at just that.
I don't get what you mean. No, I mean, I don't understand what you mean. You can explain what you mean.
No. Do you think there's a way we could try to isolate k plus 1?
T, it should be from, might be from here. If this could give us something with 6, then we can factorize 6 out, actually.
But how do we find?
Is it possible that you make it like into
3 brackets?
Yeah.
Okay, if you, no, but this cannot be factorized, right? Factors of 6 to give 2 cannot be factorized. There must be something we are not using yet.
Yeah.
And it has to be connected to the inductive hypothesis. If a number is divisible by 6, it must be divisible by 2 and 3. Right? Is this, can we show that this is divisible by 2?
You can show that it's divisible.
By 3. How?
We should have kept the full expansion.
If we do full expansion?
No, like I think we should have kept on the board just to kind of see.
Okay, let's write the full expansion again. I just erased that.
Maybe just on the side though, because we don't know the full actually.
So this is k plus 1. K cube, right? Does anybody remember the full expansion?
K cubed plus 3k squared
Plus 3k squared.
plus 8k plus
6 again?
6 plus 8k
8k
plus 6.
plus 6. That's the full expansion. Okay. Is this divisible by 3? Is there a way to find out?
If you do like the, because now you try to do the k plus 3k times k squared plus 5, that one.
This one?
Like if you write k plus 1 bracket k squared plus 5 plus 2k plus 1,
This one?
yeah, like if you separate the 6 into 5 and 1, you can prove that the whole thing is divisible by 3.
By 3.
Yeah.
But we might be able to show it from here too. Is it possible? If k cubed is 6m minus 5k, and we put it back here, if this is 6m minus 5k, then this becomes 3k, right? So everything becomes what?
6m plus 3k squared
Let's start with 3k squared. The k term
plus 3k
plus 3k
plus 6.
plus 6 plus 6m. So this is divisible by 3. But then, is it divisible by 2? This is not supposed to be the normal way, but is it divisible by 2 also? Yes.
Huh? Oh.
This is odd. This could be odd or even, right?
Wait, no,
If k is odd, no, but we don't know anything about m. M could be any integer. No. This is even. This is even, right? If k is odd, this is odd, and this is odd. This is also even. Okay? Now if k is even, this is even, this is even, this is even. So this is actually also divisible by 2. And it's also divisible by 3.